Hello, in this video I'm going to give a whistle-stop tour of the history of artificial satellites. This is something I could talk about for ages. I mean, there's so many satellites, but I'm going to just hit the high spots, talk about the famous ones and try not to go on too long. So let's go back to the beginning then with the first artificial satellite, Sputnik 1. Here's a picture of a replica of Sputnik 1. I mean, it has to be the replica because the original one burned up in re-entry to the lower atmosphere. Now, Sputnik 1, we're going back here to Cold War times. So this is the Soviet Union back in the 1950s. 4th of October 1957 is when they launched this thing. And this kick-started the space race between the Soviet Union and the US. It was, Sputnik means satellite in Russian, at least if you're using it in an astronomical context. And you can see here from the picture, we've got this sphere here, which is about 0.5 meter across. We've got these 4 radio antennae sticking out the back, and these were sending back radio signals to the Earth's surface. And it did this for about 3 weeks until the batteries ran out. And all the instrumentation, is sitting inside this sphere here. It's a fairly hefty unit for a first launch. So it's around 84 kilograms was the mass of this. As I say, it's 0.5 meter across plus the antennae, and the orbit it was on fairly elliptical, not as elliptical as they had planned. This is an elliptical orbit in the thermosphere. If you've watched my video on the Earth's atmosphere, or you're familiar with the structure of the Earth's atmosphere, we're closest approach here 220 kilometers, something like that. So that's definitely thermosphere. Out to maybe 1,000 kilometers, which could be thermosphere depending on the thickness. The thickness of the thermosphere varies quite a bit. Could be getting into the exosphere, but that's the sort of orbit it had, moving at 8 kilometers per second, orbiting the Earth every 90 minutes or so, just over 90 minutes. I think it was like 96 minutes or something like that for an orbit. So in the 3 months that it had, up until early 1958, it did around about 1,500 orbits of the Earth, and it was relaying back useful information. So, these radio signals, it was giving information about the density of the upper atmosphere, based on the drag that the satellite was experiencing. The path of propagation of these radio signals was telling people information about the ionosphere and the charged particles in the atmosphere. So you had some good solid scientific research going on here, as well as the technical side of actually building, launching this this thing. So that was straight off Sputnik 1. They wasted little time with Sputnik 2. That was the following month. So a month later, in November 57, Sputnik 2 goes up. Pretty hefty, this one. I'm not a fan of Sputnik 2. So this is over 500 kilograms. That is a substantial payload so early on. I mean, the US, as I'll get onto in a moment, couldn't match those sort of payloads. The reason I'm not a fan of Sputnik 2 is this is the one where they stuck a dog in it. So you had this dog called Laika, which they found as a stray in Moscow, and they chose it, which just makes it even worse because this dog had a particularly calm and amiable personality. They strapped the dog into this satellite. They knew there was no way that the dog was going to survive, but they stuck it up there. I mean, from what I've read of the research that was conducted by Sputnik 2, they didn't gain very much. You'd have to gain a lot for just killing a dog in such an inhumane way, and they gained very little from actually having a dog on board. So hence not really a fan of Sputnik 2. But it's one that people have heard of because, this is the first time we had a mammal go up into space. That's Sputnik 2 for you anyway. Meanwhile, the US were probably in a bit of a panic here. The Soviets had got a head start on them here in the space race. They did, February 1958, Explorer 1 goes up, the first US satellite. It detected the Van Allen radiation belts. So these are where you've got high cosmic ray activity going on. Because of the Earth's magnetic sphere, magnetic field extending out. You've got the magnetosphere extending out, way beyond what's now conventionally considered to be part of the Earth's atmosphere. And Explorer 1, it was much lighter than the Soviet satellites, about 14 kilograms, something like that. It was at quite high altitude, so it would go, up beyond 2,000 kilometers. Again, elliptical orbit, but it could be quite a long way out. And it had a Geiger counter on board. It collected about 4 months of data, again, until the batteries ran out. And this Geiger counter was expecting to get this sort of constant rate of cosmic rays turning up. But they found that every time at high altitudes they went over South America, the cosmic ray count, the Geiger counter was just returning zeros. And they actually worked out that it was saturating. There was such high rate of cosmic rays coming in to the Geiger counter that it just couldn't cope with it, and it was just giving zeros. And this was the first evidence that we had these Van Allen belts where cosmic rays were getting channeled in by the Earth's magnetic field. So although they got 4 months of data out of this, but with this higher altitude, lower mass satellite, the Explorer 1, I mean, it was still orbiting in 1970. It was up there for ages. But now you've got the US has got a foot into the space race here. And then you get this flood of satellites. They were just putting out loads of them. 1959 here, you're already on to Explorer 6 the following year. So the US are rattling through these satellites. Explorer 6 was the first satellite to take a photograph of the Earth. There it is, sort of unimpressive as it may be. I think this is going to be somewhere over Mexico or something. But there you go. First photograph taken by a satellite from space. Echo 1 in 1960. This was the first comms satellite, first communication satellite. So we're getting into all of the stuff that we're used to using satellites for nowadays. And this is all kicking off immediately. The Soviet Union, Tyros 1, however you want to say it. This was the first weather satellite. Again, 1960. So these are coming thick and fast now, these satellites. And of course, the next step was, well, let's get humans into space. And again, the Soviets took the first step here, Vostok 1. So we've now moved on here to 12th of April, 1961. Vostok 1 that is Vostok 1. It went up, it came back down. And it had to come back down because we had Yuri Gagarin on it. This was first man into space, first man to orbit the Earth. He didn't do many orbits. He did an orbit in just over an hour and a half or whatever it was. Varied from sort of 170 to around 330 kilometers, something like that. Did the orbit. Then it comes back into the lower atmosphere. When he got down to about 7 kilometers, he ejected and parachuted down. Must have been pretty nerve-wracking. It was around half of launches in the Soviet Union were unsuccessful. So sitting there on the launch pad must have been something, really. And you think, well, half of these are going wrong. I wouldn't have been so keen. The path that the orbit took, it went east across Russia, so heading over towards Japan, and it went south across the Pacific, round the bottom of South America, north up through Africa, and then landed near to where the launch was. I mean, not exactly the same place, but near. And as you can see, I mean, with the size of this and being able to support having a human on board, payload is large. I mean, we're 4,700 kilograms. Again, the US just couldn't match that sort of payload. Gagarin himself, he was in his mid-20s at the time. And of course, he's a national hero. He's known worldwide, first man into space, etc., etc. They didn't want him going back into space because it was too risky. But tragically, he died age 34 in a jet plane crash. He was a military guy. He was in the Russian Air Force. And he was only 34 years old when he died. So, yeah, pretty tragic there. But this has set off then the race for the moon of getting someone there. And we got Luna 10 This is taking us up to 1966. Soviets again, first satellite to orbit the moon. So first time we've had something in orbit around the moon, which of course leads on to Apollo 11, where the Americans got the real crown in all of this, the real blue ribbons achievement by putting a man on the moon. I mean, most people don't think this necessarily as being a satellite, but you did have people orbiting the moon. You've actually got humans orbiting the moon and then having a land on it. So from that point of view, it was an artificial satellite. And of course, here we're talking about July 1969 with the first moon landing with Apollo 11. So once you got that, and they've hit the big things here. You got first man in space, first man on the moon, etc., etc. Attention turns to all of the other planets then. So it's now a case of, well, let's get a whole load of other satellites that are going to be orbiting each of the planets or doing flybys of individual planets. So of course you're going to start with the close ones. Mariner 9, 1971. This went off to Mars. First satellite to orbit Mars. This was the US. Then you got Venera, however you pronounce it, 1975. This is the Soviets going off to Venus. First satellite to orbit Venus. Not all of them were based on, well, let's get actual orbits going on here. Voyager 1 and 2, which are pretty famous still nowadays, these were doing flybys. I mean, they noticed in the 70s that there was the planets were lining up, the outer planets. So if they set off at the right time, they could do flybys of all of the outer planets on one mission. So Voyager 2, which actually launched before Voyager 1, a little bit weird, but yeah, Voyager 2 launched a couple of weeks beforehand, and then it went through Jupiter, Saturn. So Jupiter, it flew by in 1979. I won't bother writing all these. Saturn in 1981, Uranus in 86, and Neptune in 89. So it went past all of those, the big gas planets in the outer solar system. Voyager 1 paid more attention to Jupiter and Saturn. It went to Jupiter, went Saturn. It then looked at Titan, Saturn's largest moon. This is currently, Voyager 1 is currently the furthest man-made object from Earth. It's still returning data. It's one of five, I think it's five man-made objects that have left the solar system. So, and I think it's still got the power to return data until another 5 years or something like that. But Voyager 1 and Voyager 2 have both left the solar system and they're now into interstellar space. Getting back to the satellites that were doing orbits of planets, you've got Galileo. So Galileo, this is 1995, orbiting Jupiter. Cassini went off to Saturn, so 2004. Saturn, and then Messenger went to Mercury 2014. Mercury is quite close to the sun. It poses its own challenges, even though it isn't as far away as going to the outer planets. So came that bit later. So yeah, you've got this whole string of satellites going out exploring everything that's going on. You've also got, of course, the space stations, which people have become very familiar with. Those of you who have read or remember the 80s, you had the Mir space station. So this was the Soviets before the Soviet Union disintegrated. They had the first big space station. You could get, it was assembled in space. As it would have to be when you look at the size of it. So it's a modular thing. You take up bits of it and you put it together. It was the first continuously inhabited space station. You could have 3 crew permanently there. When you could have more people for short numbers, but yeah, 3 people was a sort of permanent residency. This had a more stable, more circular orbit, sort of 350 to 400 kilometers up. So it's just orbiting around in the thermosphere. So it's going around every hour and a half. It's doing an orbit of the Earth. This then got replaced by the International Space Station, which of course is still up there at the moment. I mean, Mir was going, what, sort of 1986 to 2001. I mean, it was still operating after the disintegration of the Soviet Union, but attention started moving to the ISS. So this was 1998. It started getting constructed. Again, a modular approach is at a similar altitude to Mir. It's bigger, but this is a collaboration here, international here. We've got a collaboration between the US, Russia, Europe, Japan, Canada. It's been going for a while, as you can see. I mean, it's still there now. It's quite easy to spot it through a telescope or binoculars because it's so big, and it's going round every hour and a half. So, it can have quite a lot of flybys. You can look on a website to see the next time it's going overhead. And but now it's getting quite old. So this poses problems both in, well, we want a new one because this is great. It's great being able to do all the research on there, but you've also got the problem of how do you bring it back down? This is the largest thing that we've stuck up in space that's orbiting around. It's the largest satellite. I mean, we've had other big things go into space, but this is our largest satellite. What do? You can't just let it drop back down. With Mir, and this could be what they do with the ISS, with the Mir space station, it was controlled. You bring it down in a controlled way, and you dump it in the South Pacific, which is about as far away as you can get from any inhabited part of the world. So that quite possibly is what they're going to do with the ISS. Right, in terms of other satellites that are worth mentioning, could go on all day with all of this. I mean, I mentioned that we got 5 of these satellites have left the solar system. New Horizons, that was the whole purpose of New Horizons. That was launched, relatively recently, 2006, I think it was, and it's already left the solar system. That was the intention. Pioneer 10 and 11 that were launched in the 1970s, they have also left, but they're now dead, unlike Voyager 1 and 2, which are still sending back information. Pioneer 10 and 11 are not. I mean, they were looking at Jupiter, asteroid belt, things like that. But they're just off doing their thing. Of course, the other thing that Voyager 1 and 2 have got is they have the golden record on them. So you might have seen something like this. It's like a welcome pack for ET. So if someone finds it, some alien somewhere, then there's photos of Earth, photos of life forms on Earth, there's scientific information, spoken greetings in 50 odd languages, that sort of thing. They've got an actual recording on there. You've got the sound of whales and Mozart and Chuck Berry and babies crying, all this sort of stuff. So you get this little goodie bag for anyone who might find Voyager 1 or 2. But they're the things which are outside of the solar system. You got the Parker Solar Probe. I'm mentioning that because that's been in the news recently. It was Christmas of 2024 that it passed through the corona of the sun, and there was that nervy moment. Are we going to get connection with it again when it comes out the other side? And they did. So it's getting all this information about the magnetic field of the sun. So that's been getting a lot of news lately, as has Starlink. So Starlink, a subsidiary company of SpaceX and everything that they're doing, it's a big constellation, like an array of satellites. We're on this big sort of grid of satellites. So you've got this constellation. It's a communication thing. Loads of really small ones, thousands of them, thousands of small satellites in a low Earth orbit. So things are getting congested up there with the amount of stuff that's going up there. Which is not only a problem for putting more satellites up there. You don't want things hitting each other. You want to know what to do with the old ones when they're not working anymore. How do you bring them back down? How do you get rid of space debris? Starlink can be a bit of a pain in some ways as well for astronomy, because you can see the blinking thing. You get these pictures that people take. You just look up there and you get this big long line of lights. It's all lit up. The Starlink thing is just reflections and such like. So that can be a pain if you suddenly get that appearing in your field of view. But yeah, this is the sort of thing, the next generation of these satellites, these great big constellations of little satellites. So there you go. Like I say, that is whistle stop tour, hitting the high points of everything that's been going on over the last, well, nearly 70 years in satellites. Amazing how far everything has come in such a short space of time. What would we have done by the end of this century in terms of these satellites? It's going to be crazy, whatever it is. So yeah, there we go.